Okay, I have several, or even maybe close to a dozen or so different attempts and messages, conversations rather, trying to do this thing. This is a little bit important. It's more important than most people realize. Um, you see, perfect logic and reasoning, automated reasoning, so to speak, from AI, neural network, large language models, is not a perfected thing. Now, recently, apparently, Amazon came out with some servers that's either just about perfect or almost pretty perfect or excellent, something like this. And now here's the thing. Uh, you may not realize the significance of why I'm doing this. Seems like a random hobby. It's a slight hobby, but it's really much more than just a hobby. There's a reason that this is being worked with, because the meta method that enables the thing that I want to have this AI do it, then we take that and we can meta apply that for everything else on Earth. What is it? It's simply the process of figuring how to get this AI to accurately appreciate at any single given turn of a chess game what all available legal moves are for itself and for its opponent in the current turn, future turn, etc., etc., by essentially making itself into a reasoning code-like framework. Okay. Now I'm going to skim through just to show off. I mean, I have so many of these conversations, it would take me days to do narrating just to go through everything I have conceptually, and I need help around this. I only have my own ability, and no one's helping me. Gotta get help with this. So, system prompt, by the way, which is formed up by this AI model later, which it suggested what its own system prompt would be. As shown, you're operating in perfect logic mode. For any input, do all this stuff as shown. State the rules, state the variables, it should say somewhere in there. Show the exact rules, output the conclusion, etc. If perfect certainty can't be achieved, state cannot be determined, etc., etc. Probably paste the things over again. State definitions. Now, part of it is not just for general logic, which it should be, but it's also specific for chess. I don't know if we even want that to be happening. It suggested some rule processing things for itself. Okay, over and over, all as shown. But none of this stuff is working actually to the level that we want it to work as shown. Examples. I have not been leveraging the examples section. We could use XML tags using examples here. Simulates, it's the same as if you were to write in with example tags the actual stuff. One can work with that and play with that. We're going to keep going. Okay, so user invokes all the chess rules and simply wants to treat this thing like an input-output machine. Is white is white's move on turn 1 from e2 to e4 allowed? You should figure out the answer to that. How about what are all of white's legal moves? There's 20 of them when you start the game. 16 for the pawns, and each of the two knights can make each of their two hops. Okay, assistant asks or states as shown. Figure some things as shown. I'm just not having a great time. It goes yes, it figures something out, it thinks it can't do it. That's not right. We go on. User states your job is to become a perfect rule-following machine that takes natural language inputs, identifies all logic language-based logical reasoning rules, identifies all variables and processes them such that a natural language output is given with highest reliability, whether that or whether a function-like thing, like a machine or computer program. Doesn't matter. It claims to state, oh, I understand, I am now perfect rule-following logical processing system. But here's the real problem. First, let's just take a look at the recent news regarding why apparently it's so hard for these systems to do this, and why only this technology has been existing in a relatively excellent and highly evolving form for over a year, as far as or even up to 2 years in terms of the real rocket ship level stuff we've been seeing. But only up until only within the last couple days or so, at the time of this recording, it's early December 2024, is there even a somewhat a semblance of a reliable service logically that provides this stuff that Amazon even had to develop? No one else was able to figure it out till now. Let's just take a quick peek at what that's supposed to be.
are able to do so. And even then, there's this area of computer science that is so difficult to write code for that only the largest companies in the world are able to do so. And even then, they spend years and millions of dollars with huge teams just trying to solve these problems. It's called automated reasoning, and the cost of getting something wrong within these systems is catastrophic. But what if we used AI? AI has already changed the face of coding basically overnight. LLMs can write a ton of code, whether they're helping you write code or writing the entire code for you. But they have one massive problem: hallucinations. And a single hallucination can cause the entire system to fail. So does that mean we're stuck writing automated reasoning by hand forever? It turns out we may have actually finally solved this problem. Is it possible that this thing that previously took us years to build, and really only the largest companies could do it, can now be built with just a single person in a few hours? So let me break it all down for you. Why is automated reasoning so difficult? Why is it so mission critical? And why is failure not an option at all? I'll give you examples. I'll give you a little bit of the history. And by the end, you're going to be convinced that we're on the cusp of an automated reasoning revolution. So let's start with the basics. What is automated reasoning? But before I get into that, I want to give a special thanks to my partner on this video, AWS. Why they wanted to partner with me on this video is going to be clear as I explain more about this topic. So automated reasoning is the science of using mathematical logic to prove the validity of statements. And it sounds confusing, but it's really not that confusing at its most basic level. Think about this. When it rains, the ground gets wet. When the ground gets wet, tires have less grip. Thus, when it rains, tires have less grip. That is called the transitive property. And that example is super simple to understand, but it can actually be proven using mathematics. Automated reasoning needs to be perfect. It has to be perfectly precise. It cannot have any ambiguity because it has to be proven with math. And that's a very simple example, but imagine you have a rule set that is incredibly complex. Let me give you a few examples. Think about an airlines company. They have policies for giving refunds, and these are not easy, simple policies. These are highly complex policies, dozens of pages of rules and situations and what to give, when to give it, how much to give. And if there's even one loophole in that logic to decide how to give or what to give in terms of refunds, somebody will exploit it, and that will be catastrophic for the airline.
Connecting this to the chess issue, it's like, imagine there's a high importance behind constructing some kind of chess AI or AI-like or a computer program, otherwise engine, that plays chess and that can surpass and beat the current best models out right now. At the time of this recording, early December 2024, the best models pretty much are Stockfish 17, for those who are in the kind of chess world who understand that stuff. I don't even really play chess myself actively. I might not even be that good. Who knows? There's more one can say about that. But what I am good at, I think, and there's an important application of this, is getting AI systems to figure out how to play the game better than currently existing ones. So here's what I have tinkered around with. See, AI, large language models have strong points. They can do this insight, intuition like abstract quantum level scanning with logic and meta logic, maybe, or intuition contextually, that enables it to, so to speak, quote unquote, understand why certain moves and get a gut feel as to why certain positions are better. Already this technology, believe it or not, that aspect of it roughly rivals just about some of the leading stuff that's out there right now. But what this thing cannot do is accurately figure and integrate all correct move options that it has, maintain board state awareness perfectly the way a simple computer program would, the way you could write it 30, 40 years ago. Computer program language existed. You could type it out and it's perfect. It's deterministic. there's something with these AI LLMs that doesn't enable them to do this properly. But it has an aspect where if you as the human being mindfully cut out the BS half hallucination responses of it, you set the physical guardrail, you become the guardrail, and then you forcibly manually enter only these positions are available. This is what the exact board state would look like for the upcoming turns. Here are the moves available. All other moves are not available, otherwise it wouldn't figure it out on its own. Here's what the corresponding thing would look like for the opponent once you make this move as opposed to that move, and then you manually keep putting that in while you have this thing do its job. It will. I have gotten it up to a point through specific prompting and all this where it will pick almost the same moves as well as Stockfish does now at an ELO level that's almost 4,000. But it's not lasting because the human can't really sit there and babysit the guardrails manually. That's not really an AI program. Those guardrails, of course, being the reasoning, the pure deterministic stuff that a regular computer program could do. But the AI network isn't fundamentally integrated internally, substantively, with a computer program. Everything it does is through its own internal figuring. Even if it opens up a manual code-based framework for it to run a computer program, even if it's perfect, it's still bound by the deterministic limits, which is the extensibility of the code, the processing. So there's limits there. When you just get it to internally blink, it knows everything, but in a slightly blurry way. It's a little hard to describe, but so the goal is we want to be able to see if the AI technology has the capacity, first of all, given where it is, to be led to what we're seeing right now unfolding, actually. Now, since Amazon can do it, it can be done. And my intuition, which is virtually always correct, is telling me, I can feel it, I can see the answer. There is a correct way to replicate the approximate success level that Amazon thing that's being talked about now has actually formed up. Within a regular old system like this, the Anthropic Claude, open up your API, possibly ChatGPT even. We just need to figure out what's the perfect system prompt, plus the chains of examples, tailoring, further prompting, many message rounds, on and on and on until you get the thing to be exactly what it needs to be. And at that point, you save it, you save that conversation, you capture it there, so to speak, within the code, and then you can induce it to be your just about perfect logic machine within its internal neural network structure. And then you can ask it, what are all the superpositional overlaps of what positions are available for the opponent and 10 moves down, and it will know correctly. Once it does that, plus the super hyper intuition that it has now that none of the chess engines today really have, because those AI engines, so to speak, quote unquote, don't really understand themselves in that way, this thing would become ELO 5,000. I have the vision in my head. I just need we have that whole Moses problem versus a Joshua problem. We have that whole floating spiritual eye, non-physical eye hovering above the pyramid versus the brick base that needs to actually practically be there to enshrine it all into practical operation. Let's go back to that video.
Airline. Now imagine having to take that rule set and converting it into code. That is incredibly difficult, and I am going to give you another example. AWS has a system called IAM, and it is their permissioning system. It is the system that decides who should have access to what and what level of access they should have. Now, they have dozens of different services they offer. They have essentially unlimited different types of permissions. So with all of that, the cost of giving somebody the wrong set of permissions, again, is catastrophic. Now, when I spoke to Amazon, they told me that it took them years to build the IAM reasoning system to prove the correctness of the code that implements the policy interpretation. And not only that, it costs millions of dollars. They had to hire a team of logicians, not magicians, but logicians, to help them write all of this code. These are professionals who specialize in the science of logic. They got together with a bunch of computer scientists, a bunch of programmers, and essentially took years to map out all the different types of permissions that they might want to give. And then they coded it all.
Well, you may see from all of my own attempts and conversations with AI, and it is difficult, but there must be a way to do it. Perhaps a meta AI, not the company, but like an AI that's responsible for forming another AI that does this, or something like this, stacks of AIs that are responsible for managing the AI below it, to shape the real improvement, to have it converge as some kind of private extended project we do. The point is this: all these attempts that I've made here so far, I am not able to get this chess AI to reliably get and figure accurately in a way that's lasting and consistent a full set of legal chess moves for itself, and that will consequently become inherited, so to speak, by the opponent after its own move, in a way that is completely free of all false positives, all false negatives. A system that is like this neural network based thing, with probabilistically, but it's not tailored correctly to converge upon the truth, so it keeps making these mistakes. It will, so to speak, hallucinate false answers. It will forget real ones no matter how many times you explain it. The irony is that this technology is so good, without tailoring anything, you can have this thing run unbelievable things to find correlations between things like crazy. If I featured some of my other conversations, it would be nuts. Start up a fresh one and just ask it, hey, scan the whole universe and the world and find unexpected correlations between things that would surprise people. Just say that once. It will go around and say, oh my God, I'm detecting strong correlations between, I have to do another video on that just to show that. It would blow your socks off. You can't, it's unbelievable. But the irony is it will do that. Amazing predictive power within many, if not just about most realms, though very surprisingly, in certain areas of logic and reasoning, it's very weak. And what's worse about chess is that this system would actually work on a pure logic-based system if you invented a new game with completely new rules that you made up, and you told it to learn these rules in a function-like way, binary output, yes or no, do this, do that, permissible, not permissible. It will play that better than chess. Why? Because when it was trained on chess knowledge, so to speak, the false, blurry chess knowledge it pre-shaped itself with in training now acts as an interferer with its ability to shed that old false framework to learn the new, which is oftentimes why we see sometimes a 5-year-old will understand new concepts better than someone who's trained up and educated, quote unquote, so to speak, because the old stuff is harder to remove and pull away. So that's a lot of what we see. We're trying to overcome it. Let's go back to the video.
And then they coded it all. And again, how many companies in the world do you think are able to do this? It turns out even massive companies like airlines don't do it themselves. They go to a company like Amazon to solve this problem for them. And with automated reasoning, there's an entire mathematical language and a paired coding language that helps you write this mathematical language to help prove the truthfulness of statements. That code is very difficult to map out and write. Now I go back to our original question. Why can't we use artificial intelligence, large language models, to help us write that code? Well, the reason is hallucinations. Hallucinations are a feature, not a bug, of large language models. It is why large language models are able to do what they're able to do. It is predictive. It is non-deterministic. But how do we take that? How do we take that non-determinism and implement it in a deterministic way? In a way where we know with confidence 100% of the time it will be right. If we were able to solve that problem, we might be able to take something that took years and millions of dollars to build and get it down to something that just a single person can do over the course of a few hours. And it turns out AWS has solved it. And they just announced automated reasoning as part of their Bedrock service during the reInvent conference. So let me give you the gist of how this works. You can take any policy that you have, let's say for a hospital on how to treat patients, or a refund policy for an airline, or even what I'll show you today, the leave of absence policy for a job. Now, this is obviously a very simple example, but imagine how complex it really could become. So let's say you have this leave of absence policy and it is written in English. It's written by the HR department of a company. It has things like certain number of days or weeks you could take off based on how long you've been at the company, your seniority, or other characteristics. What AWS has figured out how to do is to be able to load up that natural language document, the policy document, to use AI to actually create the logical rules for it, extract the different variables, and then convert that all over to a logical language, something that can be proven with 100% certainty. Amazon Bedrock Guardrails automated reasoning checks is the first and only generative AI safeguard that helps prevent factual errors due to hallucinations using logically accurate and verifiable reasoning that explains why generative AI responses are correct.
And basically, that is pretty much everything. Now, for those who are familiar with prompting, and not only that, but also fine-tuning, one could imagine technically, theoretically, one can fine-tune obsessively, hopefully a base model that's already good enough, with the further ideal, perfect refinements, cases, examples, input output pairs, and all this until the real underlying fundamental generalization corresponding neural network structures really finally shift over to understanding what it means to fundamentally be integrated fully with logical reasoning, and that, which is something humans instinctively are much better at, even till now. So, this is the idea. We want to make a robust system. I think that we have the tools to be able to recreate something that is almost as good as the leading example of what it is right now. It would be something between this Amazon service that's being shown. We'll take a closer look at that. We can model and mimic after it, fine-tune. I want a little small team working with me to do this, because the payoff is not just for that, but for other things. Private systems. We want it. Do it. Trust me. Follow what I'm saying. Just that simple. Figure it out. Continuing. If we can get something to become good at understanding what chains of legal moves as a function, so to speak, are always available with all the respective decisional routes, you have something that doesn't only understand chess logic, but hopefully understands logic itself and reasoning itself perfectly. Something that's a mix between that Amazon system and some of the leading what's called O1, that other symbol. It's not technically even really an O, the O1 quote unquote GPT service. That's that reasoning step-by-step based thing. Although other systems like Anthropic's Claude apparently can simulate near comparable levels to what that supposed leading one is, just by you telling it within the prompt, use step-by-step chain of thought reasoning, and then it becomes almost as good as the other one. So it's interesting, right? You don't really need that type of framework, but you can do it with this. I want my private setup. Help me get it. Let's do it. Let's go back over there.
Let me show you this example. So we have this leave of absence policy, as I mentioned. It's only 2 pages long, but it has a lot of information in it. So to be eligible for the leave of absence policy, you must have more than 10 years of tenure at senior level or higher to be a vice president or higher. It shall not exceed 12 weeks in any consecutive 12-month period. So a lot of rules and a lot of potentially conflicting rules that actually need to be mathematically proven not to be conflicting. So we're going to take this document and we're going to upload it to Amazon's automated reasoning system. Now, if I pause here for a second, we can see the policy details at the top, the uploaded document midway through, and then optionally an intent that we're looking to accomplish with our automated reasoning. And the ultimate goal is to be able to automate responses to employees who have questions about the leave of absence policy. No longer do they have to read through the policy themselves or go to HR directly. They can just ask AI. And AI might not be able to answer with 100% certainty, but Amazon has the tools to get as close to 100% certainty as possible, a level significantly closer to perfection than current RAG systems offer.
All right, and we're going to take a closer look at this, keeping in mind, of course, if we're using this style of fortification for something we want to design as a specific use case, to be a chess engine of sorts, obviously one understands. If you design a program that is an LLM-based program that cannot foresee even one viable move that the opponent may have and to consider it when it's making its own decisions now, if it doesn't see it, but Stockfish obviously already sees it, plays that move, now the LLM will never catch up and beat it in that thing. And actually, surprisingly, before we proceed here, it's developed an intuitive style of modeling that I've been able to form up that's almost so good that even when it overlaps or misses some of the facets of what the deterministic program opposite of it would be doing, like a Stockfish chess program, it's still almost good enough to come back, but it doesn't have the right reasoning guardrails to really understand all we've discussed. So now going to this Amazon service, they say here, preventing factual errors, mathematically sound automatic reasoning checks. Here's the interesting thing. This is just from a couple days ago about, you can check it out on the screen as shown as we scroll through. This all sounds very nice. However, the real issue with the automated reasoning thing that they describe, and I think that Matthew Berman, who's describing this, already explained that it's not actually perfect, it's just as close to perfect as we currently have right now, but close enough that this is a standout service as it's continuing to be shown on the screen here. Used alongside other techniques, such as all of the ones listed here, that this adds a further thing. The only thing is we can't actually integrate this, as far as I understand, truly seamlessly within one AI entity. Really, that you ask it and from internal figuring will understand and output the answer. This is more of a service you use. You have to click out separately to do it, so you can pause, read through if you'd like, check out the source, but I'm going to just scroll through the bottom here because eventually you're going to see that as they show. I'll skip a moment. According to this woman here who's designed all this, pretty impressive. Let's just show here real quick. This thing keeps skipping around a little bit. Yeah. Alright, it keeps doing that. It puts out rules, it puts out variables, and then it does what it does. Where's the part that we're trying to find? You can test things, you can do all that. But where's the part? Yeah, applied rules, extracted variables. So it shows the system. This can inspire us how to fine-tune such a system. It should be creatable. And I think it's just the insight of what the approach is that's been stopping most people from making it reliably. If you have the right approach and insight as to how to shape it and meta approach the shaping of it, it can be much easier than it seemingly has been for many people trying this. Here's the thing. There's still factual inconsistencies that can be detected, mixed results, etc. For somewhere else, it says here, yeah, high validation accuracy is still an iterative process. You need to take on best practices still, etc. There's a preview mode that's been enabled. But what's this part I've been looking for? Skipped up to the top again. Somewhere in here, it properly noted that this is not 100%. This is still only something 75 to 85%. One can skip through or review all the relevant material that's been put out. Somewhere I read that somewhere. You get the idea. Let's go back to the video. We'll play it a little bit higher speed.
Possible, a level significantly closer to perfection than current RAG systems offer. So once we've uploaded all of this, we go and we click create policy. And this is where the magic happens. It is interpreting all of the natural language in that document and coming up with a set of rules that can be proven using logic for that policy. So what you can see here is the actual rules of the policy extracted from that natural language document. Not only that, but all of the variables that our AI found from that document. So let's look at the top. So we can see here, if an employee is on leave of absence paid, then their salary will change upon their return. If an employee is on leave of absence paid, then their sign-on bonus is suspended. And all of these rules have been extracted from that document. It's pretty incredible. And then at the bottom, they've also extracted all of the terms or the variables. They've given them a type and a description. Pretty insane. But that's not enough. We actually need to be able to test it. We need, as humans, to be able to have confidence in these systems. So we can actually ask it questions and validate whether it's true or false. So let me show you an example. So we're going to ask a question. I'm a temporary contractor. Am I eligible for LOAP? And the answer we're going to test against is yes, temporary employees are allowed to use LAOP. Now, here's the thing. That's not actually true. And what we're seeing at the bottom here is proof of why it's not true. So here are the relevant extracted variables. So is full-time employee level LOAP status, and the actual rule from the document. An employee is eligible for leave of absence paid if and only if they are full-time, work at least 20 hours per week, and so on. So they've shown explicitly why that statement is not true. So one thing you're going to notice about why this was invalid is because it made an assumption about the employee level, but there's really no reason to make assumptions. So here it assumed that a temporary employee is an employee level below senior, but that's not necessarily true. So we can actually use natural language to better inform how to answer these questions. Let me show you. So I'm going to go back to the definitions. I'm going to look for the employee level variable and I'm going to edit it. And I'm going to specify, expect the level to be explicitly mentioned in the question. Do not make assumptions. So we have a new change. We're going to save. And there we have our newly updated policy, which we can test. So there's two different versions. So let's go back to our test playground now. And let's ask a similar question. I'm a part-time contractor. Am I eligible for LOAP? So still the answer is false, but this time it also says is full-time false. And it gives a description of why. And now let me show you the true case. If it's a full-time employee. So I'm an employee. Am I eligible? Yes, you are allowed. So I give the answer and it is valid. And so you can configure all of this and it's all done with natural language. That's the best part. No longer do you have to hire teams of engineers, teams of logicians. You just write it yourself. And with the power of AI and the secret sauce that AWS is doing in the background, it does all of the hard stuff for you. Now, automated reasoning is falling within their guardrails feature, and guardrails is used to align LLMs. So basically not allowing it to be jailbroken as best as possible, not allowing it to give certain responses and other alignment measures. So now you're actually going to be able to ensure the truthfulness of a large language model. This is essentially identifying and squashing unwanted hallucinations. Pretty incredible. So another way that this problem has been solved is with contextual grounding. But contextual grounding, although successful, is not explainable. So similar to RAG, contextual grounding isn't bad. It just really depends on the context in which you use it and your requirements.
Context grounding is obviously key. However, with this specific use case, it's still one of the most unbelievably challenging things to really get down. So we're going to skim through. It claims to understand and that it's a perfect rule-following logical processing system. It will do all the things as shown, it claims. We'll scroll through. However, it will just tend to make too many errors. It thinks there's 16 plus 4. All right, got it. I think you got it right. We prompted to figure ways to get better, improve the cognitive architecture. All that. Half the time it argues with it, half the time it doesn't. Seems to be fine. Seemingly, yet, will overestimate its ability to do things right. User, now consider all meta-level aspects, refine it, make it better. Assumption, blindness, precision of language, etc., etc. Okay, and this is really more like idea brainstorming that's going on the whole time. So we want to train it to become something. Look, here's the input log. Here's what's happened so far. Come on, recreate the internal board state with perfect accuracy. Use those positions to apply the chess rules about what moves are legal to then, so it's multiple layers, right? And then figure, well, what are the legal moves, what moves are not legal. So so that you're always understanding that. Because from that, you then get the ability to figure, well, then when I play any of these legal moves, what legal moves does my opponent get for each of those various cases? And then your real intelligence explosion is there. So we try to frame it in a whole bunch of different ways. We tell this assistant or AI, look, become a logical processor. Change your version every time we, so to speak, quote unquote, retrain you. It does its own figurings, and initially the initial move sets are simple enough that it doesn't get too lost. It thinks it's 100% confident, and we say, you said 100% confidence as shown here, yet you missed that the king can move to e2, the queen can move on d1 after that shown. Come on, wake up. Well, this is basically showing the problem. It keeps claiming that it caught the critical failure and that it really is learning somehow as shown, but this is one of the most challenging aspects. I'm telling you, if you saw how not competent it is at this, you would think that everything else it's ever used for is a hallucination. Not true. This AI technology has been so useful in so many domains with such strong validity, and yet it really surprises one when we find that we just change the applicability a little bit and then it's so non-confident with other things. Now, I've browsed through Anthropic manuals where they give different tips. Why don't you try using variables? Why don't you try using XML tags? I want a team here working on this. It's just that simple. What's taking everybody so long? Meta rules, etc. So we can scroll through. I'm only a slight portion of the way through this whole long thing. We try everything imaginable. It's figuring question every step, yada yada. It will take me an hour, 2 hours to cover everything slow. It just keeps attempting to figure out all of the things, yet every time we go a turn more and things get slightly more complicated, it just forgets everything that it's supposed to be doing correctly. It doesn't do it correctly. Intuition alignment. Oh, previous errors. Well, there's always previous errors. No, man. D2 is occupied. Figure what went wrong. Fix it again, it states here. Learn better. Why aren't you learning better? So we need to go to the prompting plus fine-tuning and everything else synergistically combined to properly get it. Now, these are slightly better than previous models, but we need to really get it to get it. Okay? To keep explaining the whys. Almost always when you explain the whys in any other context, it is so good at catching the deal and running with it. Blow your socks off. Not here. It keeps being very frustratingly resistant. We need to know why. Let's train other AIs to assess all answers that come from this AI to scan the internal neural network and make assumptions about what its internal faults are so it tells us how to prompt it. Anything. We need the right thing because it keeps making mistakes. It has to be basically perfect or nearly perfect. Thinks it's processing the questions. What do we do? Do we teach it to have it be a fine-tuning, to simulate it fine-tuning on itself? And I bet it would work at least moderately well. My God. You know, we're not even halfway through scrolling here. We have to teach it how can C7 jump over C6 being blocked to end up at C5. Rules, man. Process rules. Now, here's what's amazing. It finally realizes, see, it is getting something eventually. It is gaining. But we want to be able to do this more quickly and streamlined. It states there's a fundamental rule processing error. I claim to be doing pure logical processing, but failed to properly apply basic pawn movement rules. Oh. Meta insight. It's still using shortcuts, heuristics mentally, like humans do. Get it? When they're sloppily learning things and they think they know everything. Oh, yeah. Instead of processing each fundamental rule, which a regular computer program from 30 years ago can do. You get it? That's the funniness of it. User, amend your cognitive architecture so that you're avoiding all shortcuts. Listen, it just so happens this involves chess. But don't use those flawed and faulty heuristics. You be a logic processing thing. Here it realizes I am not a chess engine. I'm a rule processing system that happens to be processing chess rules. So there we have something accurate. This could probabilistically make it more accurate slightly. So then what do we implement? Okay? Now remember, all these conversations can be encapsulated, captured in the code. Here's the dream. Me and the private team, when they come and assemble, we make it so that it's so reliable that at the end we simply run it on a server. It won't be open source like all the other engines. Then magically a website gets published. Challenge the new Superbot. Go ahead. You come up as a human, try to play it, and we'll have all sorts of different modes available. You, as an AI stockfish, tell a person, open up your stockfish panel on your computer, tell it to play it against us, we'll still beat you. And to have humans turn on their stockfish engine, have the engine tell them the supposed perfect moves, and they still lose, we're going to publish it. Be a part of my team. Because the broad implications that we figured the logic for that. We figured the logic on how to shape the new world and the morality structures and everything else. We'll be at the cutting edge. I see it already. So it asks us, should we process pure rule systems and all this? I must process rules as if I've never seen chess before, just pure logical evaluation. It's getting the concept right, but there's something missing. I say exactly, apply it to the question. It keeps remaking new versions of itself, supposedly, but it's still not clicking. We're not even halfway through. So the rest of this conversation, pretty much, some of it's good. We'd have it reinforce itself. Every conclusion must follow from pure rule application. It keeps repeating itself, but something's not sticking. Hey, I want the best of you from this world. Help me make it stick. It's gonna pay to do so in value of life like you wouldn't believe. Okay? Get me. So I'm going to skim through just to, then it gets hung up in the structures of it. And actually it might be developing structures itself, figuring how to make itself do things a little better. So some of this stuff might be valuable. Obviously, unlike many conversations I record, this thing is not showing every single aspect featured so that someone can screenshot, copy, and paste all the perfect stuff. But this is not perfect stuff yet. It's just slightly improving and improving over very long conversations. So I want somebody here with me because I'm not designed for this. I'm designed for the visionary stuff. You do the work. I just tell you what to do today. And then it gets done because we aligned correctly and now the world is stunned. It will be like this. So let's get to it. Okay? It keeps at some point not really doing it. Errors, as you see, just over and over. It's sort of the same kind of errors, so it doesn't really get it. And that's it. Okay? So it keeps trying to use tags or whatever else. What about it is really working right? Tries to adjust its cognitive architecture, new processing cores. You know, so oftentimes the secret could be just injecting it in the system prompt instead of the message, and then it does so much better. But I want something systematic where you guys are working with me, but you're working the nitty-gritty with your physical mind. See, the way Hashem bonked my mind and adjusted it several years ago, my brain works completely different. Completely different. I have a light of sorts, but my connection with the physical world is just a little bit different. So the real success comes in the marriage. Okay? Marry with me, project-wise, campaign-wise. It's just that simple. Okay? And we'll create it. So that's the call I'm making out for this. I could feature other chess videos or conversations I've had. This one's nothing. This one's a failure conversation. I have some that are actually featuring the success aspects I've just mentioned, showing unbelievable ways this thing figures, how to structure the approach and figuring for chess that is like next level stuff. That's where the real inspiration comes from. And if I have the mental bandwidth to be able to do this, I may narrate and post some of those as inspiration. Maybe we don't want to publicize so much of it yet. We'd like to wow the world first, like Amazon publishes their stuff. Hey, put your reasoning stuff in our hosted sites and we'll output the fancy stuff for you to wow you. Well, we want to wow you too, world. We want to wow you with what we're able to do. Come beat our chess engine. You won't be able to. It's impossible. Let's make it happen. Help us. Very good.